Z-test problems for the true population mean. Remember, sigma is known or n is at least 30. One of those two will have to be satisfied for you to call it a Z-test instead of a t-test. Only one, but both can be satisfied. This first problem, I'm going to do the traditional method, and then if possible, we'll do the p-value method. And I am going to break it down for you, even though basically step by step I do show here, but I will be going to the sheet, the supplementary handouts, and the tables to show you the details. Here we go. A shoe manager claims the average cost of a pair of tennis shoes is $89.95. A sample of 68 pairs of tennis shoes has an average cost of $90.26. The standard deviation of the sample is $3. At alpha equals 5%, is there enough evidence to reject the manager's claim? You may want to read that more than one time. A shoe manager claims. I'm going to circle that word. Look for that word. The word problems do not always say claim. Sometimes it says someone feels something, believes something, states something, reports something. If you're lucky, it does say claim. The average, another key word, because then you'll know that's mu. Average cost of a pair of tennis shoes is, another key word, is, because you know that means equal to $89.95. There's your claim, everybody, in the first sentence. A sample of 68 pair of tennis shoes had an average cost of $90.26, and the standard deviation of the sample is $3. So that's S, not sigma, sample standard deviation. At alpha equals 5%, is there enough evidence to reject the manager's claim that the average cost of a pair of tennis shoes is exactly $89.95? This would be a z-test based upon the fact that my sample size is 68 pairs of tennis shoes. Even though sigma is unknown, it is okay. The standard deviation of the sample is given, S, but my sample size is 68. Based upon the fact that the claim is equal to, when we go to our sheet here, equal to, not equal to is the only possibility for the setup, which is step 1. So equal to $89.95, not equal to $89.95 is the two-tailed z-test for the mean. And I write the word claim by the null. The next step would be to find the two critical values. And this is from the z-table. And you would actually take your alpha of 5% and divide by 2, and you get 2.5% in each tail. That means you would either do invert norm, 0.025, or you would look up 0.025 in the two-page z-table. I'm going to do invert norm, second distribution, and I'm going to put in 0.025. The mean is 0, the standard deviation is 1 because it's the z distribution, paste. And you receive a negative 1.96 as a z-score to 2 decimal places accurately. Plus and minus 1.96 would be your two critical values that mark your rejection regions. And the z-table, remember you have to look up the area below the unknown z-score. And that area is here, 0.025. And when you work your way out and up, negative 1.9, negative 0.06 is a negative 1.96. So again, there's your z-score. By symmetry, it is plus and minus 1.96. You could also look up the area below the unknown positive z here. And that area would be, if you wanted to look that area up, it would be 1 minus the 0.025 in the right tail. So the area below it's 0.975. And if you look that area up in the two-page z-table, you will receive 1.96. You could also do invert the norm, 0.975. And that gives you your positive 1.96. Invert the norm. You have to put in the area below the unknown z and also the 2-page z-table, you have to look up the area below the unknown z on the z-axis. Test statistic time. This is my favorite part. $90.26 minus the claim of $89.95 from step number 1, divided by sample standard deviation over the square root of n. Work on that, everybody, and you should get 0.85. And you could do it a couple different ways. 90.26 minus 89.95. Enter. Divided by parentheses, $3. Divided by the square root of 68 parentheses. And I don't need that parentheses. And there we go. Enter. And that would be 0.85 because it is a type of z-score you would round to 2 places accurately. Even though it's a test statistic, it is a z-score. This is another part that I like is you take your test statistic of 0.85 and you put it in your picture. Obviously, 0.85 falls between 0 and 1.96, so do not reject the null hypothesis, and this is the null statement. Do not reject the null. When you look at your summaries and your possibilities, you put your finger on the fact that you remember your claim is the null, that it's equal to 89.95, and your decision, do not reject the null. And that's because your test statistic falls in the non-rejection, non-shaded, non-critical region, so do not reject the null. And we would do this. Claim is the null. Do not reject the null. There's not enough evidence to reject the manager's claim that the average cost of a pair of tennis shoes is $89.95. There is not enough evidence to reject the manager's claim. And that's basically all you can say to conclude the problem. There's just not enough evidence to reject the claim that the average cost of a pair of tennis shoes from the manager is $89.95. Now, since we made a 100 on this problem, and that's wonderful, there's still the probability that we made a mistake in not rejecting the null, and that's a type 2 error, which is beta. Not rejecting the null when it could be actually false. Not rejecting something that's false would be a mistake. This not rejecting the null in this particular problem does not mean that we accept the null as true. In hypothesis testing, you are never proving something to be absolutely true or false. There's always the possibility that you made a mistake in your decision, and that's alpha and beta. Here, the possibility of mistake is beta because we decided to not reject the null, which means there's the probability of not rejecting the null when it's actually false. Not rejecting something that's false is a possible mistake. That is the traditional method for this problem. Problem number 2. The manager of a large factory believes, instead of saying claims, that the average hourly wage of employees is below $9.78. A sample of 18 employees has a mean hourly wage of $9.60. The standard deviation of all salaries, all salaries everywhere, assume the variable's normal. At alpha equals 10%, is there enough evidence to support the manager's claim? Now, the manager is claiming that average hourly wage, mu, is below $9.78 per hour. A sample of 18 employees had an average of $9.60, and the standard deviation of all salaries, that word all means the entire population of salaries, so that implies that sigma is known, population standard deviation. At alpha equals 10%, is there enough evidence to support the manager's claim that the population average hourly wage of all employees is below $9.78? When you go to your phrases, below means strictly less than, which is here, is less than, is below, is lower than, is shorter than, is smaller than, or is decreased from. And that's less than here in your phrases. Once you know that your claim says less than, and again, your claim would be that the average is less than 978, you would go to your possibilities of setups, and the only place that you see less than is the left-held setup. The null is greater than or equal to, but the alternative is strictly less than, and this is the only possibility for step number 1. So greater than or equal to 978 versus less than 978. This time the claim is the alternative hypothesis, so I write it beside the alternative here. This is a z-test because even though my sample size is small, sigma is known. All salary, standard deviation of all salary. So it's a z-test for the mean. Connect Math. If you go to Connect Math and they ask you for the setup, this is the difference. The null will have strict equality to the $9.78, and the alternative will have less than $9.78. The claim is still the alternative hypothesis. So this is Connect. And the back of the textbook, the new edition of the textbook, is still a left-held z-test for the mean because less than points to the left. We have one critical value and it's negative, and we shade the left tail of the standard normal distribution, and that is all of your alpha of 10%. So you could do invert the norm 10% or look up 10% in your 2-page z-table, work your way outside the table, and you get a negative 1.28 for your critical value. I'll just very quickly show you invert the norm. Second distribution, 10%, paste. And if you round to 2 places, you get negative 1.28, and that's your negative critical value. Again, look up this area of 10% in the 2-page z-table because it is the area below the unknown z, and when you work your way out, you get a negative 1.28. The test statistic is the 960 from the sample mean minus my claim of 978 divided by my population standard deviation of $1.42 divided by the square root of 18. And you get a negative 0.54, and I'll plug this into the calculator for you. Enter. Negative 0.54 to 2 places accurately. Put the negative 0.54 in the picture. It is larger than a negative 1.28, so it doesn't fall in the left tail, which is our rejection region. It actually falls in the non-rejection region. So decision, do not reject the null statement. And I like to remind myself, okay, do not reject the null. What was the null statement? The null statement said greater than or equal to, so we are not rejecting that statement. And you go to your possible summaries. You put your finger on the fact that your claim this time was the alternative that it said below 978. And your decision, do not reject the null, and that leads you here. There is not enough evidence to support the manager's claim that it is below 978. Doesn't mean the manager's wrong necessarily. It just says there's not enough evidence to support his claim that it's below $9.78. Based upon our claim and our decision, this is the summary. That means, all in all, we still have the possibility of beta type 2 error, not rejecting the null when it could be false, not rejecting the null when it could be false, could be the possibility of a mistake. Calculator. For the last problem, I did not show the calculator, but I'd like to show the calculator with this problem. Go to Stat and Test, number 1, enter, z-test for the mean. Again, input. If they give you raw data, you'll let it blink on data and press enter. That they did not give raw data. We did not have to put it into the L1 column. Mu sub 0 is the claim of 978. below 9.78. But you just put in $9.78. Mu sub 0 is the claim. Sigma is the $1.42. Sometimes you'll have to put in, because it's a z-test, even though it says sigma, you're either putting in sigma, population standard deviation, or S, sample standard deviation. X bar is $9.60. Sample size is 18. Now you have three choices here, and you arrow and press enter. These choices are asking you for your alternative hypothesis, not equal to, less than, or greater than. Let it blink on less than because our claim or our alternative was strictly less than $9.78. And then you could choose your color with the new addition. I'm just going to let it stay blue. And then calculate. But remember, mu sub 0 is coming from step 1, the claim. And then the mu here, the three choices, would be your alternative hypothesis, which is also step 1. This is where you're telling the calculator that this is a left-held z-test for the mean. And then calculate. And what it gives you is your test statistic of z equals negative 0.54 and your p-value of 0.2954. And I'll tell you how to calculate that by hand. And you do round to 4 places accurately with p-values. But notice it did not give decision. It did not give critical values. It did not give the summary statement. So the only useful thing that it did give in terms of, the traditional method is the test statistic or test value of negative 0.54, z equals negative 0.54. It's not until we do the p-value method that the calculator becomes very handy in helping us make our decision, the p-value. So that is problem number 2, z-test. Problem number 3, and I believe I cover the traditional method again. A manufacturer states that the average lifetime of TV sets is more than 84. So states that the average lifetime of TV sets is more than 84 months. More than is this symbol. The standard deviation of the population is 10, so that's sigma. 100 sets are selected, that's your sample size. The average lifetime of the sample, that's X bar, 85.1 months. Test the claim that the average lifetime of sets is more than 84 months. In this problem, they give you the claim at the beginning and at the end, and let alpha be 1%. So population standard deviation sigma is 10 months. They take 100 TV sets. The sample average lifetime is 85.1 hours, months. Alpha is 1%, and this is a z-test because sigma is known. They do say population standard deviation. And also, it just so happens our sample size is 100, so both conditions are satisfied, even though I only had to satisfy one. When you go to your phrases, if you didn't know that more than meant greater than, you could go to your phrases and you would see that it's this symbol. And once you see this symbol, you go here, and this symbol more than occurs here, so it's a right-tailed z-test. Less than or equal to versus greater than. And you cut and paste this to your paper, so here's step 1. Less than or equal to 84 versus greater than 84. Again, the claim is the alternative hypothesis this time. If you are doing connect math, the null statement will be mu equal 84, but the alternative statement will be mu greater than 84. And the alternative is still the claim from the manufacturer. That's the only difference. The null in Connect and the new edition of the textbook has equality, whereas the old edition is less than or equal to. Next step. Critical value, there's only one and it's positive. And that is the alpha that they give us of 1% in the right tail. Do not divide alpha by 2. If alpha of 1% is in the right tail, that means 99% falls below it. So you would do invert norm 99%, or you would look up 99% in the 2-page z-table. When you work your way out, you get 2.33 as your critical value. This time I'll show you the two-page z-table instead of invert the norm. But the area of point 99, the closest one to it is here. .9901. If you work your way out to 2.3 and up to 0.03, you get 2.33 for your critical value. And that's the area below this unknown z-score, and the unknown z-score is 2.33. Or you could do invert the norm, probably faster that way. Then test statistic time. The sample mean minus the claim of 84 divided by 10 over the square root of 10 is 1.10. I will not put this into the calculator since I feel that you should practice this until you receive 1.10, and then you'll know how your calculator works. Putting 1.10 in the picture, again, 1.1 is smaller than 2.33. It falls in the non-rejection, non-critical, non-shaded region. So do not reject the null hypothesis, and the null hypothesis said less than or equal to 84. So we're not rejecting this null statement. Once again, there's just not enough evidence to support the claim of the manufacturer that the average is above or more than 84 months. If we go to our chart, we put our finger on the fact that the alternative is the claim, and our right finger on the fact that we do not reject the null. The claim said more than 84. Do not reject the null. There's not enough evidence to support the claim that it's more than 84. So it's here. Again, beta's the possibility we made a mistake, not rejecting the null when it could be false. Not rejecting the null when it could be false, which we'll never know. But it's the possibility of a mistake. This particular problem, I'll put into the calculator, and it looks like this. Go to Stat, arrow to Test, Z-test. The claim is 84. The standard deviation is 10 months. The sample mean is 85.1. Sample size is 100. The alternative hypothesis points to the right, so greater than the claim of 84 is the alternative hypothesis. And then calculate. Enter. Again, it only gives the test statistic of 1.10 and then the p-value 0.1357. Doesn't give the decision, the summary statement, the critical value. Just mainly with traditional method, it will give you the test statistics. So basically, the only thing it allows you to avoid doing by hand is step 3, the test statistic formula. The TI-84 is helpful here only when it comes to the traditional method. Okay? Next problem is a raw data problem. And I am also going to be teaching the p-value method for this raw data problem. I will go ahead and tell you, because of time, that I will just go ahead and tell you the average, the sample mean, and the from this raw data. I'm not going to put it in the L1 column. I really feel by this point, test 4, you should be able to put this raw data in your calculator. A motorist claims that the Southborough Police issue an average of 60 speeding tickets per day. Now, notice it did not say they issue below 60 or above 60, at most 60, at least 60. They issue 60, exactly 60. The following data show the number of speeding tickets issued each day for a period of 1 month, and basically that's 30 days here for this problem, so 30 pieces of data. Assume the population standard deviation sigma is 13.42. Is there enough evidence to reject the motorist's claim that alpha equals 5%? Use the p-value method. Okay. Now, you could go through the traditional method on this, but I'm going to just focus on the p-value method, and it's 5 steps. If you do go through the traditional, then it will agree with decision and summary that we have here for the p-value method. Obviously, they give population standard deviation is 13.42, so we know this is a z-test based upon that alone. Also, if you count up your raw data, there are 30 pieces of data, so it's a z-test for the mean. When I put this into my L1 column, or if I calculate the sample mean by hand, I get 59.9. I rounded to the nearest tenth according to Chapter 3 because my raw data values are whole numbers. Go to the nearest tenth, one more decimal place. Sigma's 13.42 and 30 days, and alpha's 5%. So here's the setup. Since the motorist claims that they issue exactly 60, that means equivalent to 60. Did not say below 60, above 60, at most 60, at least 60. They said they equal 60 speeding tickets. So it's going to be equal to versus not equal to from your possibilities of setups. And this is the two-tailed z-test for the mean. The claim this time is the null hypothesis because the motorist claims that they issue exactly 60. And then the test statistic, 59.9 minus 60, which is our claim, divided by sigma over the square root of n is a negative 0.04. And the reason I jumped to the test statistic is because in the p-value method, state the null and alternative hypotheses, determine the test statistic from formula, determine the p-value from test statistic, make the decision based upon the comparison of the given alpha and the p-value you found, and then make the summary statement. If alpha is greater than or equal to p-value, reject the null. If alpha is less than p-value, do not reject the null statement. And let me show you how you find the p-value from the test statistic. That's step number 3. So step 1 was the setup. Step number 2, we're not finding critical values. We're going ahead and finding the test statistic here to 2 places accurately, negative 0.04. We take this test statistic and we use our 2-page z-table to find the p-value. And this is what you do. You draw your standard normal distribution, your z-axis, your mean of 0. You put your test statistic where it should fall, and obviously it's negative 0.04, so it indicates an area in the left tail. Because this is a two-tailed z-test for the mean, we will also indicate a positive 0.04. The area in these 2 tails total will be your p-value. I just mainly work on finding one area and then doubling the area because of symmetry. So in the 2-page z-table, I look up a z-score of negative 0.04, which is my test statistic. And where your 2 fingers meet in the table, that's the area below it. So negative 0.04 is here. 0.4840 is the area below it. It's hard to show all of that. But negative 0.0 and then up at the top 0.04. Your 2 fingers meet at 0.4840. Let me remove this. And you can see that in my picture here. That means the area above 0.04 is 0.4840. So the p-value is 2 times that area, which is 0.9680. You could also do normal CDF here to get this area in the left tail. There's a couple of different things you could do. And let me review that with you. Normal CDF, negative E, 99. As a reminder, use the negative key down here. And the E is here. It's a double E in blue above the comma button, but when you press second comma, you get a single E, and then the number's 99. To negative 0.04, which is our test statistic. And that's going to give us the area in the left tail. If this were just a left-tailed z-test, that would be our p-value, 0.4840. But since it's a two-tailed, we do have to double it. 0.9681 is what we get with normal CDF, by the way, if we double it. But you know what I should have done? I should have taken the 0.4840 and multiplied by 2 to get 0.9680, which agrees with what we have in the table. So before I multiplied by 2 here, I should have went ahead and rounded 0.4840 to 0.4840, then multiplied by 2 to get 0.9680. You could also do normal CDF. Some people do this, and they want to find the unshaded area. So that's the area between negative 0.04 and positive 0.04. And then you subtract that from 1. And that gives you the area in the left tail and right tail total. But that does give you 0.9681. It would have been, if I would have rounded the area in the middle to be 0.0319 and subtracted from 1, 0.9681. So there's a little bit of a discrepancy there if you do it that way. So this time you use normal CDF, negative infinity to negative 0.04, find the area in the left tail and double it, and that's your p-value. When you plug this problem into the calculator and you go to stat and test, number 1, z-test, the claim is 60 speeding tickets. The standard deviation is 13.42. The sample mean is 59.9. The sample size is 30. The alternative hypothesis is not equal to. And then calculate. It will give us the p-value, and sometimes the p-value by hand and the p-value by calculator do not agree. The p-value by calculator is 0.9674. By the way, the test statistic is negative 0.04, but the p-value by calculator is 0.9674. On the test, I will be only asking you for the one that you received by hand, so there is a little bit of a difference. Again, the test statistic from step 2 determines the p-value. We actually put the test statistic on the axis. It's a z-score where it should fall. Find that area that it indicates in the left tail and double it because it's a two-tailed z-test. The decision. Alpha compared to p-value. Alpha, if you remember, was given to be 5%. And it doesn't matter which p-value I decide to use, the one by hand or by calculator, alpha is less than. And I tell my students this. Always put alpha first and then p-value, and then I have an open box here that's waiting for a symbol. And I make it look just like this sheet. In that open box, you either put greater than or equal to, or you put less than. Obviously, I would have to put less than, so do not reject the null hypothesis would be your decision. And the null was equal to. So do not reject the null statement that they issue exactly 60 speeding tickets, mu equals 60. So what does this mean in terms of a summary statement? When you go to your summaries, you put your finger on the fact that the claim was that they issue exactly 60, which is the null. The claim is the null. But we do not reject the null, which is our decision, so we're here. There is not enough evidence to reject the claim that they issue 60 speeding tickets. Doesn't mean the claim's correct or 100% true. There's just not enough evidence to reject the claim, the motorist claim. Here. Because we do not reject the null, it's the possibility of a type 2 error, which is beta. And there's your summary. There's not enough evidence to reject the claim that the motorist makes that they issue exactly 60 speeding tickets. And beta is the possibility of mistake. that's the one problem dealing with the p-value method. I believe this is the last problem, and it does deal with, actually there are two more, the p-value method as well. A college professor claims that the average cost of a paperback textbook is greater than $27.50. A professor claims average mu is greater than $27.50. A sample of 50 textbooks, that alone says it's a z-test, for the average cost is $29.30. That's your X bar. Sample standard deviation S is $5. Find the p-value for the test on the basis of the p-value should the null hypothesis be rejected at alpha equals 5%. Now, greater than is the claim. When you go to your expressions, if you don't know that, you can use your expressions, but then you go to your sheet and you look for greater than. Less than or equal to versus greater than is your setup, so this is a right-tailed z-test. Less than or equal to 2750 is the null, greater than 2750 is the alternative, and that's also the claim in this problem. They take a sample of 50 textbooks. The average cost of those 50 is $29.30. The sample standard deviation is $5. Alpha is 5%. This is a z-test alone just because my sample size is 50. It's a right-tailed z-test. You could do the traditional method with this problem, but the problem does say focus on the p-value method. So we go and find the test statistic immediately, and the test statistic is $2.55 here. $29.30 minus my claim of $27.50 divided by $5 over the square root of 50. By the way, if this is Connect Math, the null is equal to $27.50, and the alternative is greater than $27.50, and the alternative is still the claim, greater than $27.50. If it's the new addition or Connect Math, the null is equal to $27.50, equal to. So this is the difference. Old addition, new addition, the null statement. I like this. Now, to find the p-value, put your test statistic on the z-axis, and you would actually look up 2.55 in your two-page z-table and find the area below it. Or you could do normal CDF. If you do normal CDF, you will put in 2.55, comma E99, and that's your p-value, which is 0.0554. Let me show you that. You don't have to double it this time because it's a right-tailed. So normal CDF, 2.55, E99, paste, and that's 0.0054 to 4 places accurately. And that's your p-value. Or you could go to your two-page z-table and look up a z-score of 2.55. 2.5 here and 0.05 here. 0.9946 is the area below it. So there's 2.5 and there's 0.05. 0.9946 is the area below it. But that's not your answer. The notes that you see here are from the one-page z-table. So let me tell you, the two-page z-table, the area below it is 0.9946. Excuse me. Yes, 0.9946. So that means the area above it is 1 minus 0.9946, and that's 0.0054. So your p-value is 0.0054. In the calculator, when you go to Stat and Test, and you go to Z-Test, the claim is $27.50. The standard deviation of the sample is $5. Even though it says sigma, they did give sample standard deviation, but it's still a z-test because n is 50. X bar is 2930. N is 50. And greater than is the alternative. And then calculate. And the, I went a little bit too fast. I apologize. Everything else should be the same here, so let me do that again. There we go. P-value, though, by calculator is 0.0055 to 4 places accurately. And notice the test statistic 2.55 is still the same as what we got by hand. Now, decision time. Compare alpha and p-value in this order and wait for a symbol in the box. You either put less than in this box or greater than. The given alpha was 5% and the p-value is 0.0054 by hand and 0.0055 by calculator. Obviously, alpha is greater than or equal to. Now, we know it's not equal to. We know it's strictly greater than. But, again, the best thing to do is to follow this sheet. Either put in greater than or equal to as comparison or less than. So finally, we have an example where we will reject the null hypothesis. Reject the null statement that says less than or equal to 2750. Reject the null statement. Our claim is the alternative that it's greater than 2750. And we are rejecting the null statement that says less than or equal to 2750. That means our summary statement is going to be left finger on the claim that is the alternative. Right finger reject the null. There is enough evidence to support the claim that it's greater than 2750. There is enough evidence to support the claim. The claim was the alternative. We decided to reject the null statement that said less than or equal to, so there is enough evidence to support the claim that said greater than, more than. And that would be your summary. There is enough evidence to support the claim that it's greater than 2750 or more than 2750. Alpha this time, level of significance, which is 5%. We have a 5% chance that we made a mistake in our problem. Even though you have 100, on the test. A++++, good job, way to go. Alpha is the possibility of rejecting the null, which is what we did, when it could be true. We may never know that it could be true, if it is true or what, but it is the possibility of the mistake, rejecting the null when it's actually true. Again, p-value method, you will not double this. You use your test statistic to find your p-value. You will not double because it's a right-tailed z-test. The last problem, I'm not going to go over the details, but I just want to tell you that it is another two-tailed z-test where you have to find your p-value and utilize the p-value method. You will have a test statistic of negative 2.61. Since it is two-tailed, you will have to double this 0.0045 in the left tail, which is determined by your test statistic. You could do normal CDF and then just multiply by 2. You could use your two-page z-table. But do make sure you go over this problem with a special cable. But it's another two-tailed test. And it focuses on the p-value method. That concludes the lecture on the z-test problems for the mean. The next lecture will pertain to the t-test problems for the true population mean, and I will teach you the traditional method and the p-value method in that particular section, and using the t-table as well. Thank you. God bless. Practice these z-test problems. They're really not that bad. Know both the traditional and the p-value methods.